So this video is to help explain how a difference quotient works. So the difference quotient is given by f of x plus h minus f of x divided by h. So I'm going to illustrate that using an actual example here. So if you look at the graph of f of x equal 3x, you see that I've graphed it there in purple. I'm going to have us look at two points here. So at x equals 1, we get the y value of 3. And then at x equal 4, if we were to go further up here, we would get the value of 12, since this is y equal 3x. Okay, so what I want to illustrate here is that if I look at these two values, so for f of x plus h, it would be 12, because that's the y value corresponding with the 4, subtracted by the 3, which is the y value corresponding to x equals 1, divided by h, which is representing the difference between these two x values, which in this case is 3. Notice that we get 12 minus 3, which is 9 divided by 3, which works out to 3. Now, this is not a coincidence. We're going to see in a second why that value is what it is. Let's take a look at whether this works for the negatives as well. So let's look at -2 and let's look at -3. So the corresponding y value for -2 is going to be -6, and the corresponding y value for -3 is going to be -9. Okay, so in this case, so similarly now we'll use the difference quotient to see what we get here. So our f of x plus h is actually our f of -2, because that's the one that we moved up to, our plus h. And so in that case we get a -6 subtracted by -9, our two y values, divided by this difference, right, which is +1. This gives us -6 plus 9 divided by 1, which is just 3. So this is not a coincidence. This 3 is coming from the function with which we were working, which is our f of x equal to 3x. And notice that it's the slope of that line. So how does this work for quadratics, or something that is nonlinear? So we'll look at an example of a quadratic here, f of x equal x squared plus 3x minus 4. Okay, the equation is right here. And again, let's pick 2 points and see what we get for our difference quotient. Okay, so we'll choose -4 for our x, because that's -4, 0. And let's look at, well, that's not going to be very helpful. Let's look at -2 on the x, which gives us -6 on the y. Okay, so in this case, our f of x plus h, let's just write the difference quotient out, minus f of x over h. So this one is going to correspond with our f of -2, which is -6. This one will correspond with our f of -4, which is 0. And then our h is this distance from here to here, right? From our first x to our second x, which is a distance of 2. Notice that h continues to be positive. This gives us -6 divided by 2, which is -3. Now, does this vary depending on our points? So let's take a look at 2 other x coordinates. So we'll look at our, let's do at 1, which gives us 0. And let's look at our 2, which gives us 6. Will we still get a -3 is the question. So in this case, our f of x plus h is 6, subtracted our f of x, which is 0, divided by our h, which is the distance from this x to this x, which is just a 1. Wait a minute, now we get 6 divided by 1, which is 6. That's different from what we got earlier. So why would that be? Now notice this is not a linear equation, and so we don't have this concept of slope that's constant. We do have slopes, and that's what you found, but those slopes will vary depending on which points you're looking at, or which part of the quadratic. So why don't we, for now, just evaluate our difference quotient just on the function itself. without being at any particular point. And you'll see in calculus how these answers are important, which is, it's nice that you're getting exposed to it now. So we have x squared plus 3x minus 4. And what we want to do first is we want to find f of x plus h. And what that means is just replacing our x's with x plus h's. So x plus h squared plus 3 times x plus h minus a 4, which notice is not impacted by h, so that stays constant. Properly distributing out and multiplying x plus h times x plus h gives us x squared plus 2hx plus h squared. Doing the same for our 3x plus 3h, and then keep that minus 4. Okay, look to see if you've got any like terms. So x squared, 2hx, h squared, 3x, 3h, and negative 4. I don't see any, so we'll leave that alone. So there is our f of x plus h expression. Okay, now the next part, this part right here, asks us to then subtract f of x. So what does that mean? So now I'm going to subtract f of x, which means I am subtracting my x squared plus 3x minus 4 polynomial, right? Well, if I'm subtracting it, it's like multiplying by -1 and making sure that all of these terms are changed accordingly. Now to really subtract, I'm going to look for things that can be subtracted. I see an x squared and x squared, that sums to 0, right? The negative x squared. I see a positive 3x and a negative 3x, those are going to sum to 0. I see a negative 4 and a positive 4, those are going to sum to 0. So what am I left with? Let's write it in red. We have our 2hx, our h squared, and our 3h. And the last part tells us to then divide by h. Dividing by h is going to give us 2x plus h plus 3. Okay, if you can, try to make a connection between this difference quotient and our original quadratic, which was x squared plus 3x minus 4. Okay, this would be our response to finding the difference quotient. Good luck.